Welcome back to the Deep Dive. Today we're diving into a stack of sources that truly defines bleeding-edge science. We're talking about taking something as abstract as a quantum state and proving it can be instantly transferred across continents.
It's a huge topic. Our deep dive today is all about the revolutionary reality of quantum teleportation. And it's really important to clarify right at the top what we mean by that.
Right. Not science fiction.
Not at all. Teleportation here is the transmission and reconstruction of the state of a quantum system. You're moving its information from one location to another, but without physically moving the actual particle itself.
Exactly. It's not beaming matter, it's beaming a blueprint. And this isn't just a concept anymore. It's a technology that's developing so fast, and it really challenges our whole intuition about distance.
It does. And we're going to cover two remarkable sort of converging threads today. First, the latest physical milestones, these record-breaking achievements in the race toward a global quantum network.
And second, and this is where it gets really interesting, is the surprising conceptual parallels this science shares with, ancient, deep philosophical systems, specifically Advaita Vedanta.
It turns out the deepest physics and the deepest metaphysics often end up speaking a very similar language, a language of non-separation.
So we've broken this down into three core pillars for you. First up is that technical race. We'll look at the Misha satellite and new quantum repeater breakthroughs.
Then we'll dig into the fundamental law that makes all of this possible and also limits it, the infamous no-cloning theorem.
And finally, we'll explore that philosophical resonance. We'll touch on non-dualism, the constructed self, and what quantum mechanics might tell us about the nature of the observer.
It's quite a journey.
It is. Okay, let's unpack this, starting with the incredible distances we've already conquered in this new quantum space race. When you talk about distance in quantum communication, you really have to start with a landmark achievement by Chinese physicists back in 2022, the space itself.
Right, the Misha satellite. They successfully teleported quantum states between two ground stations that were 1,200 kilometers apart.
Just an incredible distance. It shattered every previous record.
And it's fascinating to understand why space was necessary. You see, on the ground, long-distance communication faces two huge hurdles. First is just photon loss. The quantum state degrades very, very quickly in optical fibers. You're capped at a couple hundred kilometers max.
And the second problem is you can't just boost the signal, can you? Not like with classical internet.
No, you can't. You can't just amplify a quantum signal without completely destroying it. That's a direct consequence of a law we'll get to in a bit.
So Misha's, this low Earth orbit satellite, it kind of solves both issues at once.
It does. The photons travel through a near vacuum, so there's minimal interference.
Yeah.
And the satellite acts as this independent source, distributing entangled pairs of photons down to the two ground stations, Lijiang and Dalinga.
And the quality, the fidelity of this transfer was really the key piece of evidence, right? They reported an average fidelity of around 80%. What does that number actually tell us?
That 80% is everything. It's the gold standard confirmation. See, the theoretical maximum fidelity you could get using only classical physics to guess the state is about 67%.
The classical limit.
Exactly. By hitting 80%, they proved conclusively that this was true quantum teleportation. They were really transferring an unknown state non-locally.
And the method they used, they called it prior entanglement distribution. So Misha sends out these entangled photon pairs, one to Alice's station, one to Bob's. Then Alice does her measurement.
And that's the real innovation for building a network. Misha's acts as an independent, trusted third party. It establishes that entangled link before the teleportation even begins. It's a huge step toward building a secure, intercontinental quantum network, a quantum internet.
But, while Misha's is handling the intercontinental links, the network still has to work on the ground. And that means you have to solve that problem of information degrading in fiber optic cables.
Which brings us to the next critical challenge: building affordable, reliable quantum repeaters. These would let us chain together lots of shorter, stable quantum links over thousands of kilometers.
And this is where our breakthrough from the University of Stuttgart in November 2025 comes in. They managed to teleport quantum information between photons that came from two different quantum dots.
It sounds like a really minor detail, but it's a massive technical hurdle. When you use separate sources, like these quantum dots, the photons they produce are always slightly different, in their timing, their frequency, or color.
And if they aren't identical,
the whole thing fails. Entanglement, teleportation, it all just breaks down.
So why is it so important to get two separate sources to work together?
Scalability. It's the only way to build a real network. If every single node in your repeater had to be this single, perfectly tuned, custom source, it would be impossible to mass produce.
So what the Stuttgart team did was engineer quantum dots that were almost identical to start with, and then they used something called quantum frequency converters to fine-tune them.
Yes, to iron out those tiny differences. They're basically standardizing these inherently unique particles. It was a proof of concept over about 10 meters of fiber, but it proved the fundamental idea. We can now use two independent sources to feed information into a chain. And that's exactly what a ground-based quantum repeater needs to do.
It's amazing. All these incredible technical marvels, the satellite, the quantum dots, they all hinge on entanglement. And this astonishing physical rule. Let's get into the core mechanics of how a state actually gets transferred.
Okay, so the absolute foundation is shared entanglement. Alice and Bob are two parties. They have to share a pair of entangled particles. Let's call them particle 2 and particle 3. Their fates are linked no matter how far apart they are.
And Alice has particle 1, which holds the unknown quantum state she wants to send. And it's critical that she doesn't actually know the state.
Absolutely critical. If she knew it, she could just, call Bob and tell him, this is for teleporting an unknown state. So Alice performs the crucial step, a Bell state measurement, or BSM. She takes her particle 1 and her share of the entangled pair, particle 2, and she performs this very specific interaction on them. It kind of mixes their information together.
And that measurement forces those two particles into one of 4 possible entangled states.
Mm-hmm. And here's the magic. The moment the BSM happens, Bog's particle, particle 3, which could be light years away, is instantaneously projected into a state that is mathematically related to the original state of particle 1.
That's the part that sounds like it breaks the laws of physics. It feels like faster than light communication. How does the universe prevent that?
Well, it prevents it with the no cloning theorem. This was established back in 1982, and it's a fundamental law. It states that it is impossible to create a perfect, independent copy of an unknown quantum state.
You can't just quantum photocopy it.
You can't. So if you can't make a copy, what does that mean for Alice's original particle, particle 1?
It has to be destroyed.
It's destroyed. During that Bell state measurement, the initial quantum state on Alice's side is fundamentally and permanently gone. So particle 3 on Bob's side isn't a clone, it's the result of a transfer. The original has to vanish for the new one to appear.
So the destruction of the original is what maintains that speed of light limit. But Alice still has to do one more thing, a classical thing.
Precisely. The result for BSM tells her which of those 4 states her particles collapse into. She has to send that result, just 2 classical bits of information, to Bob over a normal channel. An email, a phone call, whatever.
Okay, so if I'm getting this right, Bob instantly receives this projected state, but it's sort of scrambled, and then he gets a regular speed of light message from Alice, which is like the passcode to unscramble it.
That's a perfect analogy. The instantaneous part is quantum, but Bob can't use the state until he gets Alice's classical passcode. That passcode tells him exactly which correction, which transformation to apply to his particle. Once he does that, particle 3 perfectly matches the original, now destroyed state of particle 1.
So the useful information only travels at the speed of light.
Exactly. The transfer of usable information is gated by that classical step. The speed of light is safe.
When you really slow down and think about that, reality itself requires destruction at one point for reconstruction at another. It's this deep, non-local connection that just defies our everyday idea of separation.
It really does.
And this is where we can shift gears and look at these conceptual parallels that they've captivated thinkers for thousands of years.
Right. This idea of non-separability or non-dualism, it has incredibly deep roots. We're talking about Advaita Vedanta, which is a philosophical system built entirely on a non-dual understanding of reality.
So Advaita posits that the ultimate reality, which it calls Brahman, is this singular unified consciousness. And everything we see, all the individual things in people, the phenomenal world, it all just arises from that underlying unity.
And the resonance with entanglement is just fascinating. Entanglement is the strongest correlation possible in nature. Measuring one particle instantly influences the other, no matter the distance. It's what Einstein called spooky action at a distance.
Because it seems impossible.
It seems impossible if you believe 2 distant things are truly separate. So both the science and the philosophy are challenging that core assumption. Quantum physics proves that far-flung particles can be fundamentally connected. Advaita argues that the apparent distinctness of the world is an illusion covering up an underlying unity.
This challenge to independent existence also comes up when we think about the role of the observer, doesn't it?
We know from quantum mechanics that the act of measurement causes a system's superposition to collapse into one definite state.
And for a while, that led some people to speculate that maybe human consciousness itself was the cause of that collapse.
It did. But it's important to say the scientific consensus today strongly rejects that idea. Mainstream physics favors physical mechanisms like decoherence, just the system interacting with its environment, to explain collapse. Human consciousness isn't seen as necessary.
Right, but the parallel comes back in a different way when we talk about the self.
Yes. Cognitive science and philosophy now widely propose that our sense of self, our ego, what Advaita calls ahakara, is a kind of constructed model. It's a useful fiction the brain creates to navigate the world.
And that mirrors the Advaitic goal perfectly. The whole spiritual practice is about transcending that constructed, separate identity to realize your true, unified nature, the Atman.
Both frameworks are suggesting that the separate self we experience every day is a phenomenal construction, not a fundamental reality.
And there's one more parallel. Wave-particle duality.
Right. Quantum entities can act like a wave or a particle, these contradictory things, depending entirely on how you set up the experiment. The context of the measurement determines the reality you see.
And this duality finds its mirror in the Advaitic concept of Maya.
Exactly. Maya is the power that projects the world of multiplicity, making the unified reality of Brahman appear as all these diverse things. But crucially, Maya is called Anirvachaniya, indescribable. It's neither absolutely real nor absolutely unreal.
So it's a contextual truth.
It's a contextual truth. Just as a quantum entity appears as a wave or a particle depending on your setup, from the perspective of ignorance or avidya, Brahman appears as the material world through the power of Maya.
So both the physics and the philosophy are telling us that reality is fundamentally contextual. It resists our need to put things in rigid either boxes.
It's a remarkable common thread, isn't it? Linking a satellite orbiting the Earth to texts written thousands of years ago.
This has been an incredible journey. We've traced a line from these huge technical breakthroughs using space with mesis, solving the quantum dot puzzle for repeaters on the ground, all the way to ancient philosophy.
And every single technical advance is built on the unique physics of entanglement and that no cloning rule, which says the original state must be destroyed for it to reappear somewhere else. It's a path that, conceptually at least, seems to mirror that philosophical journey towards self-knowledge.
We have proven scientifically that the deepest level of reality is fundamentally non-separable. It is entangled over vast cosmic distances. So, if our world emerges from this underlying unity, maybe the ultimate challenge isn't just perfecting a terrestrial quantum repeater.
Maybe it's mastering the internal contemplative methods needed to realize that we too are fundamentally non-separate from that unity.
It does raise a final provocative thought. If separation only appears when we measure it, or when we construct an identity, then maybe the biggest error in classical thinking, both in science and in our lives, was ever believing in true, independent isolation in the first place.